Hello all. Let us solve the book back MCQs and detailed numericals for chapter 2. I have made it as a video recorder, so please have the volume up and go through these steps. Okay? Do it properly. I think you can copy it into your notes. Thank you. So the following graph shows current versus voltage values of some unknown conductor. What is the resistance of this conductor? So it is for one conductor, so we can directly use Ohm's law. So Ohm's law is V is equal to R into I. So this is in the form of an equation of a straight line. Y is equal to mx. So here the analogous is, in the place of x we have I. So current is given in the x-axis, voltage is given in the y-axis. So in the place of y we have voltage. So the slope of this line is the resistance of the conductor. So slope m is equal to dy by dx. So here resistance r is the slope. So this y dv by di. dv is v2 minus v1 by i2 minus i1, which is, let this be 1 and let this be 2. You can take any point in between. So let us take initial and final point. So at 1, current I1 is equal to 0, V1 is equal to 0. At 2, I2 is equal to 2 and V2 is equal to 4. So coming back, we have 4 minus 0 by 2 minus 0, which is 2 ohms. So the value of the resistance of the unknown conductor is 2 ohms. That means option A. So question number 2, a wire of resistance 2 ohms per meter is bent to form a circle of radius 1 meter. The equivalent resistance between its two diametrically opposite points A and B as shown in the figure is. So what is given is, there is a conducting wire. The resistance per unit length, per meter length is given as 2 ohms. So the resistance per unit length, R by L, is given as 2 ohms per meter. So the total length of the wire that is required to form a circle of radius 1 meter is actually the circumference of the circle. So total length of the wire is equal to, circumference is 2 pi r, which is the circumference. R is given as 1 meter, so this is equal to 2 pi into 1, which is 2 pi meters. So total length of the wire L total is equal to 2 pi meters. So if the length is 1 meter, the resistance is given as 2 ohms. If the length is 2 pi meter, the total resistance can be found out by R total is equal to resistance per unit length into L total, which is 2 into 2 pi, that means 4 pi ohms. So the total resistance of the wire which is bent to form a circle is 4 pi ohms. The question here is the equivalent resistance between its two diametrically opposite points. So A and B are the two diametrically opposite points. This 2 points split this circle into 2 equal halves. So when the length is circumference, it is the full circle. AB splits it into 2 equal halves. That means this half is half of the circumference and this is half of the circumference. That means The total resistance is split into 2 and the arrangement looks like between the diametrically opposite points. Let this be A. This is equivalent to 1/2 of the circumference and these are connected across the terminals A and B. The total resistance is 4 pi. AB splits the circle into 2 equal half. So the resistance for the upper part, this part of this circle is R total by 2 and the bottom part is again R total by 2. So let this be R1, which is R total by 2 is 2 pi. Let this be R2, which is again R total by 2 is 2 pi. For resistors in parallel, arrangement, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. 1 by R1 is 1 by 2 pi plus 1 by 2 pi, which is 2 by 2 pi 1 by pi. So 1 by R equivalence is equal to 1 by pi. That means R equivalence is equal to pi ohms. That is option A. Do you understand? Question number 2. A wire of resistance 2 ohms per meter is bent to form a circle of radius 1 meter. The equivalent resistance between its two diametrically opposite points A and B as shown in the figure is. So what is given as resistance per meter length? So this is, we are taking it as small r, which is resistance per unit length, which is given as 2 ohms per meter. A piece of wire is bent to form a circle of radius 1 meter. So you are using a wire and you bent it to make it as a circle. So what is the total length of the wire required? So L total required is actually the circumference of the circle. Circumference of the circle will give you the total length of the wire. So circumference is 2 pi r. R is given as 1 meter. So the radius of this circle is 1 meter. So this is 2 pi into r, which is 2 pi meter. So L total is equal to 2 pi meter. So 2 pi meters of length of wire is taken to bend it in the form of a circle of radius 1 meter. But what is the total resistance involved? The specific resistance R is equal to R by L is 2 ohms per meter. What is R total is equal to? R total is R into L. So R total is equal to small r into L is L total, which is 2 ohm per meter into L total is 2 pi, which is given as 4 pi. So R total is 4 pi. This is the total resistance of the entire wire, okay, which is basically the circumference. The length of the wire, total length of the wire is the circumference. But if this diametrically opposite points A and B split this circle into upper half and lower half. So the length of the wire in the upper half is total length by 2 and the length of the wire in this portion is again total length by 2. That means the resistance is halved. If you cut it into, like, it is made like this. This is upper half semicircle and this is lower half, which is again another semicircle. Let this be the two diametrically opposite points A and B. So the total resistance is 4 pi, and if it is, see, this AB divides the circle into two equal halves. So this total resistance is again split into two equally. So let the upper portion, if this is AB, this is R1, R1 is equal to 2 pi. 2 pi is nothing but half of the total resistance 4 pi. Here R2 is again equal to 2 pi. Okay. So for parallel arrangement, for parallel configuration or parallel arrangement, the equivalent resistance is given as 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So 1 by R equivalent is equal to 1 by 2 pi plus 1 by 2 pi, which is 2 by 2 pi. 1 by pi. 1 by R equivalence is equal to 1 by pi. Therefore, R equivalence is equal to pi ohms. Question number 2, option. Option A. Question number 3. A toaster operating at 240 volt has a resistance of 120 ohms. Its power is, what is the power of the toaster? So the given data is, what is given? V is equal to 240 volt and resistance is given as 120 ohms. You are asked to find the power P. We have 3 equations. We know 3 equations to calculate the power. P is equal to I square R or VI or V square by R. So we can use the formula based on the data given. So we are given V and R. That means we can calculate using this formula, V square by R. So power P is equal to V square by R. What is V square? 240 square by R is 120. I can write this as 240 into 240 by 120, which is 2 times. So 2 into 240 is 480 watts. So the power of the toaster is 480 watts. You understand? Option C. So question number 4. A carbon resistor of 47 plus or minus 4.7 kilo ohm to be marked with rings of different colors for its identification. The color code sequence will be. So for this question, refer to page number 94. This table is color coding for resistors table is given. So the first color indicates the first digit, second ring indicates the second digit, third one indicates the decimal multiplier, and the last one is the tolerance metallic band, which is either silver or gold. If nothing is given, the metallic band is not given, it means you have to treat it with 20% tolerance. Okay, so this is given in page number 94 in your book, refer to that. So for us, what is given is the resistance value is given as 47 plus or minus 4.7 kilo ohms. So this is 47 plus or minus 4.7 into 10 power 3 ohms. Okay, so plus or minus this 4.7 is the tolerance. Okay, so without tolerance I will write it as 47 into 10 power 3 and the tolerance is 4.7. 4.7 is actually 10% of this total resistance value. This is 10% of this value. So go with the first digit. First digit is this one, 4. So for 4, number is number 4. So it is going to be yellow. Yellow ring. Second digit is 7. So the color corresponding to 7 is violet. You check here. This is yellow. This is yellow for 4, violet for 7. Okay. And the multiplier, what is the multiplier given? 10 power 3. For 10 power 3 it is orange. So multiplier 10 power 3 corresponds to orange. And 10% of 47 is 4.7. 5% is 2.35. So if it is given as 2.35, you have to consider it as 5%. Okay. If it is 9.4, it is 20%. That means colorless. But here it is 10%. So 10% tolerance corresponds to silver. This is 10%. This corresponds to silver. So the color code will be yellow, violet, orange and silver. Yellow, violet, orange, silver, option B. That's it. Question number 5. The concept is similar to the previous problem, but here the color rings are given and you are asked to find the resistance value of the following resistance. So the first color band is brown. So brown corresponds to 1. So the first digit is going to be 1. Second band color ring is black. Black corresponds to 0. So second digit is 0 for us. Third ring corresponds to the multiplier, which is given as yellow. For yellow, the multiplier is 10 power 4. So this corresponds to 10 power 4. We have gold ring. This corresponds to 5%, but you are asked to find the value of the resistance. So the resistance R is equal to first digit, second digit and the multiplier is 10 power 4. Okay. So this is equal to 100 into 10 power 3 ohms. So this is equal to 100 kilo ohms. The resistance value R is equal to 100 kilo ohms. If you are asked to write it including the tolerance, for gold it is going to be 5%. So 5% of 100 is 5. So the tolerance, with the tolerance, R is equal to 100 plus or minus 5 kilo ohms. But the option given here is without considering the tolerance. So this is the answer. The resistance value of this resistor is 100 kilo ohms. Got it? Right. Two wires A and B with circular cross section are made up of same materials with equal length. Suppose RA is equal to 3 times RB. Then what is the ratio of the radius of wire A to that of B? Let us consider this as wire A and wire B. Both are having circular cross section, right? So this is circular cross section. If the cross sectional area, the view is circle. So both have cross sectional area as circle. And the lengths are also the same. This is LA, this is LB. It is mentioned that they are of equal length. So LA is equal to LB and they are made up of same material. So same material means rho A is also equal to rho B. This is length, equal length. Is made up of same material, so they are talking about the resistivity, which is one of the properties. Okay. What is given as RA, resistance of wire A is equal to 3 times resistance of wire B. Okay, this is given. What is asked is find what is the ratio of the radius of wire A to that of B. Small r is radius. You are asked to find RA by RB. So capital RA by capital RB is equal to 3. This is comparing resistances. This is resistance ratio. You are asked to find the radius ratio. Okay. So we start with the equation that relates resistance, resistivity, length and area. What is that? R is equal to rho L by A. We know that resistance is directly proportional to L and inversely proportional to A, and the proportionality constant is rho, which is resistivity. Okay. So if we write this equation for wire A, we can write it as RA is equal to rho A LA by AA. Similarly, RB is equal to rho B LB by AB. Okay. So RA by RB is equal to, let this be equation 1, let this be equation 2. 1 divided by 2 is giving you RA by RB is equal to rho A LA by AA divided by rho B LB by AB. Rho A is equal to rho B, LA is equal to LB. So RA by RB becomes AB by AA. What is AB? Pi RB square by pi RA square. I is same. So this is equal to RB square by RA square. What is RB square by RA square? In the left side we have RA by RB, which is given as 3. So this is square, RB square by RA square is equal to 3. So RB by RA is equal to root 3. But what is asked is RA by RB, which is equal to 1 by root 3. 1 by 1.732, which is less than 1. So RA is less than RB. That means option C. Okay. Question number 7. A wire connected to a power supply of 230 volt has power dissipation P1. Suppose the wire is cut into 2 equal pieces and connected parallel to the same power supply. The power dissipation is P2. Then the ratio P2 by P1 is. Consider there is a wire. Okay. It is connected across a power supply of 230 volt. Okay. This is 230 volt. And the power dissipation is P1. So the relation is P is equal to V square by R. Okay. So P1 is equal to V1 square by R1. Okay. In the second case, you are going to cut this into 2 pieces and this wire is connected to the same power supply. Okay. So let this be one portion of the wire and let this be the second portion of the wire. Both are connected in parallel and connected to the same power supply of 230 volt. This is again 230 volt. Here the resistance was R1 and the supply was taken as V1. Here V2 is also 230 volt, but the resistance is cut and split into 2. So if R was the resistance initially, this is cut into 2 means it is split into 2. R by 2, this one is R by 2. Let this upper portion be 1 and second portion be 2. So when resistance are connected in parallel, equivalent resistance 1 by R equivalence is equal to 1 by R1 plus 1 by R2, which is here 1 by R by 2 plus 1 by R by 2. This is 2 by R plus 2 by R. 2 by R is 4 by R. This is 1 by R equivalence. But R equivalence is equal to R by 4. This is R equivalence for the parallel combination. Okay. Again, P2 is equal to what? V2 square by R equivalence. This is 2. V2 square by, what is R equivalence? R by 4. This is equal to 4 V2 square by R. V2 square is equal to V1 square. Both are 230 volt, right? So this is equal to 4 into V1 square by R. What is V1 square by R1? R1 was R. So this is P2. This is, sorry, that is P1. P2 is equal to 4 times P1. So P2 by P1 is equal to 4. Option D. Question number 8. In India, electricity is supplied for domestic use at 220 volt. It is supplied at 110 volt in the US. If the resistance of a 60 watt bulb for use in India is R, the resistance of the same 60 watt bulb for use in USA will be. So you are comparing the resistance of a 60 watt bulb in two different countries where the supply voltages are different. So what is given as, in India the supply voltage is V India is equal to 220 volt. V in US is equal to 110 volt. Okay. The bulb used is, the resistance of a 60 watt bulb in India and USA are getting compared here. So the bulb rated power is 60 watt both in India and the US. So you're asked to find the resistance in the US. So find resistance in the US. If the resistance in India is equal to R, we know the equation for power. P is equal to, we are determining the resistance, and what is given is the voltage. So the power equation in terms of voltage and resistance is V square by R. This is India, this is India, and this is India. Similarly for the US, this is equal to V US square by R US. So the bulb part is same. So this is 60 is equal to, what is V in India? 220 square by, what is the resistance in India? In India the resistance is R. So let this be capital R. This is for India. For the US, the bulb is again 60 watt. V in the US is 110 square by R US. Okay. So this is R India, which is given as R. So R is equal to 220 square by 60. Here also R US is equal to 110 square by 60. Okay. R US by R India. This R means R India. Okay. R is equal to 110 square by 60 divided by 220 square by 60. So this is 110 into 110 by 220 into 220. So this is 1 by 4. So R US by R India is equal to 1 by 4. So R US is equal to R by 4 ohms. That means option C. Okay. Question number 9. In a large building, there are 15 bulbs of 40 watts, 5 bulbs of 100 watts, 5 fans of 80 watt and one heater of 1 kilowatt are connected. The voltage of electric mains is 220 volt. The maximum capacity of the main fuse of the building will be. See, the fuse capacity, as I have already mentioned, when the current is in excess, what gets fused is the fuse wire. So the capacity of the fuse is mentioned in terms of current, that is amps. Okay, so we are going to find the current flowing through the configuration. So power is given, power of different appliances are given, and the voltage is given. You are asked to find the current. Okay, so we know the power equation is P is equal to V into I. So voltage is given as 220 volt, and you are going to find current. I is equal to P total divided by the supplied voltage V. So these are connected in parallel configuration. The total voltage across each this appliance is going to be the same. So what is P total? We are going to calculate the total power of all the appliances. So we have 15 bulbs of 40 watts. So this comes around 600. And then there were like 5 bulbs each of power rating 100 watts. So this is 500 watts. And then 5 fans each of power rating 80 watt. So this comes around 400 watts. And then this is for bulb. This is again for bulb, 100 watts bulb. This is 40 watts bulb. This is for fan. And the last one is heater. There were like 1 heater of power rating 1 kilowatt. 1 kilowatt is 1000 watts. So this comes around 1000 watts. So total power is 2500 watts. Okay. So substituting in this equation, I is equal to 2500 divided by supplied voltage is 220. So it comes around 11.36 amps. The closest value is, so I is approximately equal to 12 amps. Okay. Option D. Question number 10. There is a current of 1 amps in the circuit shown below. What is the resistance of P? So this is the supplied voltage plus to minus. It passes through 3 ohms, then to 2.5 ohms, and then through an unknown resistance P. Okay. So you are asked to find the resistance value P. Okay. The current through a series circuit is going to be the same. So I is same. The current that flows through all the resistance are going to be the same because they are connected in series. So I is given as 1 amps. Okay. So by Kirchhoff's voltage law or loop rule, we know that the net EMF is equal to the sum of the product of current and resistance. Okay. So in this loop, it is going this way. Okay. So the net EMF is 9 is equal to current I pass through this. I is equal to 1 amps flow through all these resistances. So the product of current and resistance is first this one 3 into 1. This is first across first resistance plus the same 1 amps flow through this 2.5 as well. So 2.5 into 1 plus this 1 amps flow through this resistance, unknown resistance P. So this is P into 1. So 9 is equal to 3 plus 2.5 plus P. P is equal to 9 minus 5.5. So P is equal to 3.5 ohms. Option C. Question number 11. What is the current drawn out of the battery? So we can see there are 3 resistances connected in parallel across a 5 volt supply. So first we are going to find the equivalent resistance for these 3 resistors which are connected in parallel. So 1 by R equivalence is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Let this be R1, R2 and R3. So this is 1 by 15 plus 1 by 15 plus 1 by 15, which is 3 by 15, 1 by 5. So 1 by R equivalence is equal to 1 by 5. R equivalence is equal to 5 ohms. Okay. You are asked to find the current drawn. The supplied voltage is 5 volt. Okay. V is equal to IR. I is equal to V by R. The supplied voltage is 5 and R is also, equivalent resistance is also 5. This is equivalent. So this comes around 1 amps. The current drawn from this battery is 1 amps. Question number 11, option A. Question number 12. The temperature coefficient of resistance of a wire is 0.00125 per degree Celsius. At 20 degrees Celsius, its resistance is 1 ohm. The resistance of the wire will be 2 ohm at what temperature? So we know the temperature dependence of resistance or resistivity, and we know the formula. If you recollect the formula, it says you can either go with rho or R, but what is given is R. So the resistance at any temperature T was given as R0 into 1 plus alpha into T minus T0. RT is the resistance at any temperature T. R0 is the resistance at temperature T0, which was usually mentioned as 20 degrees Celsius. Here also it is given as 20 degrees Celsius. And alpha is the temperature coefficient of resistance of the wire. So what is given is at 20 degrees Celsius, when T0 is 20 degrees Celsius, R0 was 1 ohm. RT is equal to 2 ohm, which that corresponds to what temperature? That is asked. Let us write here. R0 is equal to 1 ohm at T0 is equal to 20 degrees Celsius. RT is equal to 2 ohms at temperature T is equal to some T. You are asked to find this temperature. The temperature coefficient alpha is given as 0.00125 per degree Celsius. Substituting in this formula, RT is 2 is equal to R0 is 1 into 1 plus 0.00125 into T is not known minus T0 is 20. So let this 1 comes here. This is equal to 2 is equal to 1 plus 0.00125 T minus multiply 0.00125 into 2. So this comes around 0.025. So keep this on one side. So 2 minus 1 plus 0.025 is equal to 0.00125 T. 2 minus 1, 1 plus this is 1.025 is equal to 0.00125 T. From this T is equal to 1.025 divided by 0.00125. So this comes around 820 degrees Celsius. The temperature was like 820 degrees Celsius, and the resistance corresponding to this temperature is 2 ohm. So the answer was like for 12, it is D, 820 degrees Celsius. Question number 13. The internal resistance of a 2.1 volt cell which gives a current of 0.2 amps through a resistant 10 ohm is, I repeat, you are asked to find the internal resistance of a cell whose EMF is given as 2.1 volt. The current drawn was like 0.2 amps and the external resistance connected was 10 ohm. You are asked to find the internal resistance. Okay. So this is the battery with internal resistance R. This is external resistance. The EMF was given as 2.1 volt and the current drawn is the same because it is connected in series, which is given as 0.2 amps. This resistance value is given as 10 ohms. Okay. So the voltage drop across this resistance, this external resistance, is V is equal to I into R. So V is equal to current drawn is 0.2 into R is 10, which comes around 2 volt. So we know that the voltage drop, terminal voltage drop, is always less than the EMF of the cell because a part of the voltage drop occurs across the internal resistance, which is small r. Okay, this V is the voltage drop, terminal voltage drop across the resistance, external resistance. So the relation, the equation that relates internal resistance, external resistance, EMF and voltage is small r is equal to epsilon minus V by V into capital R. So epsilon is given as 2.1 minus the voltage drop, terminal voltage drop is 2 volt. So this is 2 divided by 2 into capital R is 10. 2.1 minus 2 is 0.1 by 2 into 10. 0.1 by 2 is 0.05 into 10, which is 0.5. What you are calculating is the internal resistance, so this is ohm. Therefore, the internal resistance of the cell is equal to 0.5 ohms. R is equal to 0.5 ohms. Question number 13, option B. Question number 14. A piece of copper and another of germanium are cooled from room temperature to 80 Kelvin. The resistance of option A, each of them increases, each of them decreases. Copper increases and germanium decreases, and copper decreases and germanium increases. So we have to look into this graph, which is given in page number 95 and 96, I guess. Quickly go through the graphs given. The temperature dependence of resistivity. They have compared the resistivity or the alpha value for, this is for metal and this is for semiconductor. So you should know that copper, what the two elements that are given are, one is copper and the other one is germanium. So copper is a metal. Copper is a good conductor and it is a metal. Germanium is a semiconductor. Okay. So for copper, alpha is positive, that means the slope is positive. For semiconductor, the slope is negative. What does that mean? For copper, the slope is positive means if the temperature increases, resistivity increases, right? If the temperature decreases, resistivity decreases. But for semiconductors, the slope is negative. See, if temperature increases, resistivity goes down. That is inverse relationship. So if you decrease the temperature, resistivity goes up. Okay, so the behavior of both is exactly the opposite. Okay, so for copper, what you are doing is you are cooling it from room temperature. So initially it was at room temperature, and it around, see, for normally we have in India the room temperature is around 300 Kelvin. You are cooling the piece of copper and germanium from room temperature both to 80 Kelvin. What happens to the resistance? Okay, so if the temperature goes down, for copper the relationship is positive relationship. Positive, that means if T goes down, what will happen is resistivity or resistance will go down. So rho goes down, that means resistance decreases. But for germanium, which is a semiconductor, the slope is negative, that is alpha value is negative. That means if T goes down, rho increases. If rho increases, R increases. So for copper, R decreases. For germanium, R increases. So the right option is question number 14, option D. For copper it decreases and germanium it increases. Okay. Question number 15, the last question of this MCQ section. In Joule's heating law, when R and T are constant, if the H is taken along y-axis and I square along x-axis, the graph is. So what is taken along y-axis is H, the Joule's heat, and x-axis you have taken I square. So if you draw a graph, what is the profile like? So 4 options are given: straight line, circle, parabola and ellipse. So here, to make you understand clearly, you can vary current I from 1 to 10. What you have here is I square. This is I square. Just square this number. Okay. And then I have mentioned it as, we know from Joule's heating law, H is equal to I square R into T. So what is given as R and T is given as constant. Okay. So H can be written as some constant K into I square. This K could be anything, any number. So I have taken K as equal to some 4, just for illustration. So H is equal to 4 into I square. This is I square values. When I is 1, I square is 1. When I is 2, I square is 4. So I have increased the current from 1 to 10, and this is the I square value. This H is obtained by multiplying I square this into 5, this into 5, this into 5, this into 5. What you get is this one. So when it is plotted in a graph by taking H in the y-axis and I square in the x-axis, what you actually are getting is a straight line. So the correct option is option A, which is a straight line.